In the video 2 of module 3 contents, further we'll be discussing about the law of gearing. So the law of gearing for the involute profile gear tooth. So here you can see the point of contact where it is going to move, where point P is the pitch point. The profile give constant velocity ratio and positive drive for conjugate profile, where KL it is length of path of contact, KP it is the path of approach, PL is the path of recess. So when the two gears meet, so different axis has been generated. So with respect to the wheel and the driver where it moves. So here the base circle, pitch circle and addendum circles are considered, where it is going to have a path of contact where phi is the pressure angle. If you take the angular velocity ratio omega 1 by omega 2, that is equal to O2 n by O1 of m, that is equal to O2 of p by O1 of p. So omega 1 by omega 2, that is equal to T2 by D1 is equal to T2 by T2 T1, where D is the pitch circle diameter, D is the number of teeth, where point P it is fixed. So for the common normal point of contact between a pair of teeth must always pass through the pitch point. So this condition must be satisfied. So gear meshing and involute tooth profile. Here you can see the pressure angle what you indicate. Here it is shown with respect to phi. So comparison between the involute and the cycloidal gear, it is advantage of involute gear is that the center distance for a pair of involute can be varied within limits without affecting the velocity ratio. But in the cycloidal ratio, it is not possible. And the pressure angle for the involute gear from the start of the engagement of the teeth to the end of the engagement must remain constant. And it must be smooth running and less wear of gears. So in case of cycloidal, we expect less smooth running of gears. Pressure angle is maximum at the beginning of engagement, reduces to 0 or 0 at the pitch point, starts decreasing and again becomes maximum at the end of engagement. The face and flank of involute tooth are generated by a single curve. So in the cycloidal, it is a double curve what you are going to generate, as it is in cycloidal, it is epicycloidal and hypocycloidal. So here it is difficult to manufacture in case of cycloidal gear. It is easy to manufacture in case of involute gear. In terms of strength, involute gear is less strong, and the cycloidal gear it has got more strength. So it has got wider flanks, and involute gears can be generated for the same pitch. So involute gears can occur. In case of cycloidal gears, interference does not occur. Involute gears are less weighted. Cycloidal gears are outweighed. So like this, it gives a comparison between involute and the cycloidal gear. So standard proportions of the gear system for 14.5 degree or full depth involute system, 20 degree full depth involute system, 20 degree stub involute systems. Like this, you'll be having different value. Addendum, it is common, that is 1 m we are supposed to take. So with respect to module, it is defined for addendum, dedendum, working depth, mean total depth, tooth thickness, working depth, minimum total depth, tooth thickness, minimum clearance, fillet radius and root. So here for 14.5 degree, 20 degree, full depth, 20 degree stub involute system, like this different modules are specified. So increasing the pressure angle from 14.5 to 20 degree results in a stronger tooth, but tooth is acting as a beam is wider at the base. So to calculate the length of path of contact, this diagram is considered with respect to the radius and the pressure angles. So RA, small RA and capital RA, two values are considered. So small r, it is the radius of addendum circle on pinion. R is equal to 1 of, that is radius pitch of the pinion. Like this, you are going to consider both. For that, you are going to apply the right angle triangle and calculate for the length of path of contact. So the equation it comes is r root of RA square minus of r square cos square of phi minus of r of sin phi. So length of arc of contact, what we are going to take is EPF or EGPF. So arc GP is known as arc of approach. Arc PH is called as arc of recess. So length of arc of contact, that is equal to length of path of contact by cos phi. Length of arc of recess will be able to take length of path of recess by cos phi. Length of arc of approach is equal to length of path of approach by cos phi. By using this expression and the corresponding values with the help of diagram, we will be able to calculate length of arc of contact. Contact ratio. Contact ratio can be calculated by length of arc of contact by the circular pitch of pitch circle. So m is the module. So pitch circle is equal to pi into m. The contact ratio it must be 1.6, means 1.6 pairs of teeth in contact must be there. There are alternately one pair and two pairs of teeth in contact on a time basis. The average is 1.6. Larger the contact ratio, more quietly the gears will operate.